analyzers. Let's go over chapter 3, lesson 3. Probably gonna have to take my bracelet off because it's already jingling and jangling and getting in the way, right? Am I right? Okay. Well, here we go. So, we're about to get into a pretty good Algebra 2 concept, one that I love, and it's going to be solving absolute value equations and absolute value inequalities. So, over the next 2 lessons, that's what I'm going to go over with you. And before I can really get into actual equation solving, we need to remind ourselves what absolute value really is. Because if we know what absolute value really is, then the way that we solve the equations will make a heck of a lot more sense. Okay? And what you got to remember is that absolute value is a distance measurement. Okay? It's just how far away from zero are you? If you're at 7 on the number line, you are 1, 2, 3, 4, 5, 6, 7 places away from 0. And the same is true if you're at -7 on the number line. You are 1, 2, 3, 4, 5, 6, 7 places away from 0. So as a result, what we realize about the positive and the negative that's in front of our number when it comes to being on a number line, that's just a direction. Which direction are you from 0? Are you the positive direction from 0, which is to the right? Or are you the negative direction from 0, which is to the left? Okay, so what absolute value bars, the straight up and down bars that are around our number, are doing is they are taking the direction out of the equation and just looking for the distance. Okay, so that's it. And what that equates to in our minds and in our practical use is the sign gets dropped. Okay, that's what gets equated here. So the absolute value of 7 is 7. And the absolute value of -7 is -7. Oh my God, is +7. It's just 7 away from stuff. Okay, so that's what you want to keep in mind. The negative gets dropped, which means that regular old absolute value bars can never be equal to a negative integer. Okay, it's just not possible. They're not able to be equal to a negative because they're not giving us that indication. Absolute value bars are only giving us a distance. They're not giving us a sign. And so since that is the case, if you ever have absolute value bars equal to a negative number, that's not a thing. And so that's something we're going to need to keep in mind when we go and solve absolute value equations. And so that's what we're going to be doing here. As you guys know, with your notes, I have everything all written out for you as to the procedure that I'm going to use. Okay. But I'm just going to get started in the procedure. So what I'm going to do is, I know I have example 1 done for you right here, but I'm going to do example 1 off to the side and just show you that when you are asked to solve x minus 10, the absolute value of x minus 10 equals 6, that there are 2 options that are really happening here that you have to think about. The first option that you have to think about is that this absolute value really is representing a positive 6. And so the first option is that the stuff inside the absolute value bars really is equal to 6. And so to figure out what the stuff is, this is the first scenario, okay, the first option. Figure out what this stuff right here is, you just add 10 to both sides over here. So we've dropped the absolute value bars. We've considered this is a 6. Okay, cool. So what was x having to be? X had to be 16. And then that makes perfect sense to us. So with a quick check, we can just see that 16 minus 10 in absolute value bars is 6, and 6 equals 6. But there's another scenario here. What if the stuff inside these absolute value bars was actually equal to -6? What if then when you took the absolute value, it came out as a positive? So you've got to consider that other what if when you're solving for x. We still drop the absolute value bars to do this consideration, but now we negate the other side, which means multiply it by -1. So this is now a -6 that we're considering. Because what if the stuff in the absolute value bars was equal to -6? And then when I took the absolute value, it came out to be this +6. What if that happened? Well, let's see. We still add 10 to both sides to get x alone, but this time we get 10 minus 6 is 4. So there's another possibility, and let's just do a quick check that makes sense. 4 minus 10 inside absolute value bars is -6, right? In the absolute value bars. And the absolute value of -6 is 6. So here you go. That one worked too. Okay? Now, I'm not saying I need you to write out your checks. I'm just showing you this is why anytime you solve an absolute value equation, you're going to need two scenarios. Okay. You've got to have two options. It's either that this really was a +6 that was inside the absolute value bars, or it's that this had been a -6. And so when I took the absolute value of it, it came out to be that 6. I have to consider both of those options. There's only 2 times where you don't consider those options, and I'll show those to you. Okay. So let's do some more examples. Now, the key here is you always need to have your absolute value bars completely alone before you go and do the two scenarios. So in this one, my absolute value bars are already completely alone. So I start with my first scenario. And my first scenario is, okay, drop the absolute value bars. And let's say that this was just a regular old 3 over here. Okay, well, now we just subtract that 5 from both sides. Okay, cool. We get -2x equals -2. Divide both sides by -2. And you get x equals 1. Okay, and that's one potential answer. And just real quick in my head, let me just kind of go through that. Okay, -2 times 1 is -2. -2 plus 5 is 3. The absolute value of 3 is 3. Okay, so this one works and checks out. But what if the stuff inside this absolute value had been a -3, and then when I took the absolute value of it, it comes out to be a +3, right? So I still just drop the bars, but this time I negate the other side of the equal sign. So now it's a -3 over there. All right. And so I still solve the same way that I did before. I subtract 5 from both sides, but this time I have a different value over here, a -8. And now I divide both sides by -2, and I get x equals 4. And a quick check in my head confirms that this would give me a 3, right? -2 times 4 is -8. -8 plus 5 is -3. And the absolute value of -3 is +3. That's why there are two potential answers for x in this case. All right, two potential answers for x in this case. Now, I want to remind you, you have to get your absolute value bars alone first. And so I know you're looking at C and panicking. I'm saving B for a second for a reason. But you're looking at C and panicking, but don't. Because what is the opposite of dividing by 2? It's multiplying by 2. Start by getting your absolute value bars alone, okay? Start by getting them alone. You just multiplying both sides by 2. Bring those absolute value bars down. Okay, cool. Now, 8 times 2 on that other side is 16. Now, this is the scenario you're working in, okay? There's two potentials here. Either this stuff will become a 16, or this stuff is a -16. Because either way, when you took the absolute value of it, you got 16 out here. So let's look at those two scenarios. And again, those two scenarios are drop the absolute value bars and leave the other side, or drop the absolute value bars and negate the other side. Okay? It's always two scenarios, except the two things I'm about to show you after this. Okay? It's always these two scenarios. So with absolute value bars, we want to then add 8 to both sides over here. Cool. You get -3x. Oh, I'm about to fall off my chair. I got so excited about absolute value bars that I scooched forward in my chair and I'm almost falling out. All right. And now divide both sides by -3, and you get x equals -8. Okay, real quick, I'm just going to check that just to make sure that works. And again, in my head, negative 3 times negative 8 is positive 24. Positive 24 minus 8 is 16. The absolute value of 16 is 16, and 16 divided by 2 is 8. Checks. Okay. So I did that in my head. You could always do that in your graphing calculator too. I mean, let's be realistic. We've got this for a reason. So just real quick, I'm going to check negative 8. So absolute value is math, arrow right to number, and there's your absolute value bars. And so negative 3 times negative 8, and then minus 8 gives me 16, and then 16 divided by 2 is 8. And so that's where I get that from is my check. Okay. Ooh, my calculator needs some charge in here. Uh-oh. Do that after. What if that was a negative 16 in the absolute value bars? Well, add that 8 to both sides. I get negative 3x equals, let's see, negative 16 plus 8. That's a negative 8. And ooh, I've got to divide both sides by negative 3. However, 8 does not evenly divide by negative 3. Okay, that's all right. I'm just going to leave my answer as a fraction. That works. Negative divided by negative, however, I am going to write my fraction as 8/3. You can write your answer as, and just let me show you real quick, 8 divided by 3 is, of course, 2.6 repeating. You can write it as this. That works too. I typically will keep fractional answers. Just so you kind of get used to what my answer keys will look like. I will typically keep fractional answers like this. And again, I can just check that. That's not, that big of a deal to just check. Let me just zoom out so you can see my whole deal. Okay. The absolute value, so math, arrow right to number, enter. There's my absolute value of negative 3 times 8/3. So I put that in parentheses. Minus 8 should give me negative 16, or 16 in this case, right? Because I took the absolute value of it. Okay. And then divided by 2 is 8. And that's where that comes from. So I can always do my checks on the graphing calculator as well. But I just do some quick mental checks to make sure that both of my answers work. Okay. Before we continue, I'm not going to do D. Instead, I want to rewrite this one. The absolute value of 3x plus 2 equals 0. And this is one of two scenarios where you are not doing two scenarios. There are two possibilities where you don't have to do the two different scenarios to find 2x values. One of them is 0. And here's the reason why 0 only has one thing you need to solve. Because 0 is not positive or negative. So if 0 is coming out of absolute value bars, it was never a negative 0. That was never a possibility. 0 is just 0. And because of that, if you ever have to solve an absolute value that's equal to 0, you literally can just drop the bars and solve. So we get 3x equals negative 2, divide both sides by 3, and x equals negative 2/3. And that is your one answer in this case. I believe there's one question on your homework that does that. Okay. If there's 0, there's only one scenario, because 0 is never negative. And that's why. 0 is never negative because 0 is never positive either. 0 is nothing. 0 is not a sign. In fact, 0 is what we're trying to measure our distance away from, in which direction. And so 0 is kind of that point on our number lines that we use as reference for all of this distance, right? Oh, okay. We're diverting that for the time being. All right, next. Let's head back up to this guy B that I ignored momentarily. Okay. And what I did here, and the reason I ignored this momentarily, was because I wanted to talk about these two places I don't use two scenarios. Well, remember, you got to get your absolute value bars alone first. Okay. So I start by subtracting this 8 away from my absolute value bars. I bring my bars down. I get 4x plus 6, absolute value of it, is equal to 3 minus 8 is negative 5. Wait a minute. Can absolute value bars ever be equal to a negative number? Is a negative number ever coming out of two absolute value bars that are just alone? And the answer is no. So when you have your absolute value bars completely alone because you've moved everything away from them, now you have no solutions. This is not a possible solve. There's nothing that you can plug in for x right here that is then going to come out of absolute value bars and be a negative 5. It's just not possible. Only positives can come out of these absolute value bars. So that's the case of no solutions. There is definitely one of those on your homework, so be on the lookout. Okay? Please ask me for help on these if you need them. I know this is new and this is Algebra 2. I love absolute value equations. Okay, they're so cool because, again, you're thinking about the sign droppage and just distances away from zero. And so there's these two possibilities, okay? The only times there's not is if your absolute value bars are alone and equal 0, or if your absolute value bars are alone and equal negative 5, or negative numbers, right? A negative number on the other side of absolute value bars is not going to happen. Okay? So guys, good luck, and I shall be seeing ya. Have a wonderful rest of your day. Next up, absolute value inequalities, just as fun with number lines. See you guys.